recording right now, and by tomorrow morning, I won't be able to get the file to you till tomorrow morning, but you'll be able to review it if you like. So, what problems are we going to go over? Can you verbalize them to me, or do we need to be looking at them? In other words, can you take a picture? If you could take a picture,
yeah, I can either take a picture.
Take a picture of your review sheet and send it to my email, and then I'll just pull that up on the screen, and we'll both be looking at it.
Okay, that would work fine. Okay, we did just start Riemann sums.
Okay.
And I think for the most part, I can ask.
We can probably verbalize. Yeah, we can verbalize that. What's the first problem you got?
All right. So, all right, this one, it does have a picture. However, I bet you.
Yeah,
I should actually probably.
You can tell me how many intervals they want to break it up into and what the function is. We'll do it.
Well, it's determining the area of the shaded region.
Okay. Probably going to need to send that. Probably going to need to send that to me. Unless it's, is it like one function's like that and the other's like that, and they want this like that? In other words, if you can give me the top function, just verbalize the top function for me and the bottom function, and I'll tell you how to do it.
Well, so the equation of the curve shown below is y equals 4 over 1 plus x squared.
Okay.
And then it says determine the area of the shaded region. Now this looks like a cosine graph where it starts on the y-axis and goes down on either side, and you're finding the shaded region above and square from -1 to 1.
Okay. Does it stay above the x-axis during that whole interval?
Yeah, the entire time. And the shaded area is -1 to 1.
So it's
and
like
it's
this.
Above. Yeah, correct. And it's above. So if you were to draw a box going up to the vertex from -1 to 1,
yeah,
it would be the shaded region above the cosine. So on the outside of that.
Okay. Here's how you find the area under a curve. We're going to break it into Riemann sums, rectangles, add up the area of all the rectangles. Here, let me graph this on Wolfram alpha so I know what we're looking at. Are you familiar with Wolfram alpha?
I'm not.
You should get familiar with it. It is slick. Let's see, this was 4 over 1 plus x squared. So we got 4 divided by 1 plus x squared.
Okay.
The reason it's cool is because it gives you this. In other words, a calculator, you can never know whether you got it put in correctly. But with Wolfram alpha, it shows you exactly what the function looks like, so we got it right. And then it shows a picture of it. So they want the area from -1 to 1, right? Correct?
Yeah.
Okay. So let me redraw
that's correct.
this. Let me redraw this a little more accurately. Let me look back at it again. Okay. So from -1 to 1. So we're looking at something like that.
Okay.
Okay. So what kind of rectangles? What kind of rectangles are we going to break it up into? Left, right, mid?
It does not actually say. I sent you the email of what the picture looked like.
Okay. Let me open my email up.
So essentially what I think the idea is I need to find the area under the curve in between 1 to 1. and that using not actually the Riemann sum, just using the sigma
Oh, I see now. I
and
see.
subtracting. But I'm not sure because I think you end up getting a tangent, and I'm not exactly sure
No.
kind of
What
how
we're
to
going
get.
to do to find the area of the shaded region is we're going to take the area of that rectangle and subtract the area under the curve.
Okay.
Okay? So let's see. Google has switched the way they do stuff now. They used to always have a download thing. Okay, here it is. Just in the last day, they've completely switched how you download files. I'm still adjusting to it. So let's see. Okay, shaded region problems. I like to tell my even non-calculus students, I tell shaded region problems are always subtraction problems.
Okay.
We have no idea how to calculate that area right there. Not even with calculus. Well, I know how to do it with calculus, but we generally don't know how to calculate areas that are surrounded by curves like this. Okay? However, I do know the area of this rectangle. It's 4 by 2. It's 8. So if I take the area of the rectangle, hold on. Get rid of this picture here. I'm going to take the area of the rectangle and subtract the area under the curve.
Okay.
That's going to be my shaded area. So the area of the rectangle is 8, and the area under the curve, using regular calculus, is the integral from -1 to 1 of this function.
Okay.
There's your answer. Now, how you evaluate this, you can either do that on your calculator, you can do it by hand, manually, and I presume we're not going to use Riemann sums, or we are?
Correct. This one I know, this one's on my review, and I have to do this one by hand. And I believe you get tangent, but then I'm not sure how to work with the tangent.
You don't get tangent. In other words, this isn't the cosine curve. You get inverse tangent.
Inverse tangent, yeah.
Yeah, you get inverse tangent. In other words, let's go back and review our derivatives. The derivative of inverse tan of x dx is equal to 1 over 1 plus x squared.
Okay.
So if I take this 4 over 1 plus x squared, I can always take constants out of the integral. So I can take that 4 out of the numerator, right? Haven't changed anything. Now I can integrate, and this becomes 4 inverse tan of x, and I'm going to evaluate the whole thing from -1 to 1.
Okay.
So let's do that, and that's the way you're supposed to do this, right? In other words, we're not, if you came up with inverse tan, that's not using Riemann sums. That's using antiderivatives. In other words, we found the antiderivative of 1 over 1 plus x squared. Now, do you know how to evaluate this from -1 to 1?
You take tangent -1 x, or
plug
equal
in,
to 1.
you plug in the 1, and then we subtract
and the -1.
the negative 1.
Is it 8 minus 4 each time, or you carry the 8 through, or would you do 8 minus 4 tangent negative, or? inverse
No,
tangent
you're
1
absolutely right. You're absolutely right. I don't need the second 8. What I need is proper parentheses. In other words, whenever you're doing these evaluations, the parentheses are huge because you can end up with expressions that have 5 or 6 negative signs in them. And if you don't use proper parentheses, you're going to lose a sign. Okay? So what I'm really doing is I'm 8 minus this whole thing like that.
Okay.
Okay? So now let's evaluate what's the inverse tan of 1 in radians.
That's going to be pi over 4.
Very good.
Correct?
Uh-huh. What's the inverse tan of minus 1?
Just negative pi over 4?
Uh-huh. So, what do I have here? I have 8. So this is 4 pi over 4 minus, well, that's plus pi over 4. So let's see. This becomes pi. And I have minus a minus pi. So that becomes plus another pi. So my answer is 8 minus 2 pi. The shape
yeah, there it is. Okay.
Okay.
Good deal. All right. So, next one. It's find the average value of the function y equals negative 1 over x on the interval 1 to e. And there's no graph or anything for this one. That's all there is.
Okay. We don't need it. Do you know the formula for average value? Average value is 1 over b minus a times what?
Okay. Times sigma.
Times the integral of our function.
Okay, from 1 to e. Okay, from 1 to e.
And actually it's from a to b. So if a is 1 and b is e, then I can substitute e minus 1 right there. Okay? So that's what I'm looking at solving. That's going to be my average value. Okay? So we got 1 over e minus 1. And let's take that negative out. Put it here.
Okay.
And it's times, excuse me, not minus. What's the integral of 1 over x dx? What's that?
Does that turn to natural log 1 over x?
It does. So now we have 1 over e minus 1 times a negative natural log of e minus natural log of 1 inside another set of parentheses. I think I got it right. In other words, this negative sign is this negative sign. And the integral of 1 over x from 1 to e is the natural log of e minus the natural log of 1. Okay? What's the natural log of e?
1.
Uh-huh. What's the natural log of 1?
Is that 0?
Yep.
Okay.
So that whole thing is 1, now becomes minus 1, so that's our answer. Or they probably are going to write it like this, 1 over 1 minus e. That's a better looking answer.
Oh, okay. I see how she got that then. Okay. I just dropped that negative at the end there.
You notice how
Okay.
why these two are equal? In other words, e minus 1 is the negative of 1 minus e. So I can get rid of this negative sign by switching this order.
Okay, yeah.
Okay? You have answers? Is that the right answer?
All right.
Because
That's correct.
it's real easy to make a mistake on these. The hardest thing about these is keeping track of your negative signs. Trust me.
All right. So for next one. Okay. So if a mid-Riemann sum with 4 rectangles of equal width is used to approximate the area enclosed between the x-axis and the graph of y equals 4x minus x squared.
Pull this up on
And it says the approximation is what?
use mid.
Yes.
4x minus x squared looks like this. It's parabola right there. Okay.
Okay.
And we want to use 4 rectangles.
Okay.
And we want the middle of the rectangle to be the function value.
Okay.
So this rectangle, there's the mid. Oh, went up too high. Let's see, that's got to go right through there.
Okay. So basically, because it was 4 units long, how you're dividing it is still just by each unit.
Yep, I'm splitting it up into 4 equal rectangles between 0 and 4. Okay? Now, let's talk about the area of each of these rectangles, because we want to find the area of each rectangle and add them up. Okay, so what's this first rectangle I'm looking at here, what's its base?
Is 1.
Okay. What's its height?
That's just going to be the equation, 4x minus x squared.
Not quite. F of x is equal to 4x minus x squared, right? What is this point right here? That height, the y value of that is actually f of 1/2, right?
Right. Okay, so you plug that in.
It's not f of 0, it's not f of 1. If we were using left rectangles, it would be f of 0. But using mid-Riemann rectangles, this point is halfway, so that's 1/2. So the height of that rectangle is f of 1/2. What's the height of the second rectangle?
Okay.
So there's the area of the first rectangle.
Height of the second.
This is the second
And it's
rectangle.
going to be 3.
Yes. Good. Times 1. The height of the third rectangle.
And
the height of the fourth.
5 halves.
And the height of the fourth rectangle.
Okay. And
So
you
what's
just
f
plug
of,
all of those in, correct?
yeah, f of 1/2 looks like it's going to be 2 minus 1/4. So that's 1 3/4. F of 3/2 looks like it's 6 minus 9/4. That looks like 3 3/4. F of 5/2 looks like 10 minus 25/4, which is 6 1/4. So that is also 3 3/4. That makes sense. This height's the same as this height over here, right? So the area of the third rectangle, should be the same as the area of the second rectangle. And it is. And then finally we have 7/2. What's that?
It's
and
just
7/2. Right. It's symmetrical. And then to get the last one, we do 7/2, which is 14 minus 49/4. This is going to be a smaller number. That is 12 1/4, so this is 1 3/4. Same as the first one. Symmetry and motion. So what do we have? We have 3 1/2 and 7 1/2, so we have 11. It's the area.
All right, yeah.
And that's the way you do Riemann sums. Is this notion of figuring out the height is a huge notion in calculus.
Okay.
To be able to say that that height is f of x is the key. It's just what is x? Well, x is halfway between 0 and 1, so it's f of 1/2 is the height. But if we were doing, say, if we were doing right Riemann sums, let's just do one. A right Riemann sum here would be, my first rectangle would have to be bigger, huh? It'd have to be up here.
Mm-hmm.
What's the height of that rectangle?
Okay. That one's going to be f of 1.
Exactly. Your second one's going to be f of 2, the third one's going to be f of 3, and the fourth one's going to be f of 4. So depending on whether you're doing left, mid, or right, depends on whether you do f of 0, f of 1/2, or f of 1 as the height of your first rectangle.
Okay.
Okay?
All right. All right, so next one here is if the average value of the function f on the interval a to b is 10, then the sigma from a to b f of x d of x equals.
Okay.
I have a sigma notation there, not the
Oh,
e.
not,
Does that matter?
you have a sigma, not this? In other words,
Correct.
sigma is the same as integral. Do you mean
Okay.
integral?
Yeah, I mean the integral then.
Okay. So the integral from a to b, this actually is the Greek letter for sigma. And that's where the integral sign comes from, is they've just smoothed it out. The Greeks use sigma, and I don't know who first used the integral sign. But we're saying 10 is the average value?
Well, no, they're saying that the average value is 10.
Right. So the way I've written it here,
So,
average value is 1 over b minus a times the integral from a to b of the function.
okay.
Okay? And they're saying that equals 10. What's the function?
Well,
What's the rest of the information? I can't really solve it with just this little information.
I think she's trying to keep it as variables because all my answers that I have here are in variables.
She doesn't give
And
you
so
f.
that's kind of what I'm.
She doesn't give you the f of x.
No. Like I said, I think she's just trying to have us show it in a variable. I'll go ahead and send you a picture of it so you can see.
Okay, yeah. Let me take a look. Maybe I'll figure out what she's trying to ask here. Hold on, I need to close out stuff here. Let me close this one out. Let's see, before I close this out, our next appointment is Monday night at 8, right?
Correct. Yes.
Right. I'm sorry, I'm not sure what happened on Tuesday.
Yeah.
I saw somebody attempting to make a appointment on Tuesday, but it didn't get confirmed. And I'm not sure why or whether that was you or not. But I apologize.
Yeah, I think I was.
There is one
trying to- I'm
final
not sure what
step.
happened.
Yeah, you have to confirm it after you make it. And some people forget that confirmation and then it doesn't come through. Whether that's what happened or
Okay.
not, I don't know. But I apologize either way. You could have called me. I'd have been happy. Even if you called me 10 minutes after I didn't show up, that's fine with me. You know,
Okay.
if you think that there was supposed to be an appointment and I don't contact you, obviously I got my signals crossed, but I'm still happy to do it. Okay, so let me close out my calendar here, because to open up my email, this GoToMeeting really stresses my CPU, my computer chip. It is a real power hog. And
Yeah, drink just.
I can't run very much. In fact, I'm hearing some static right now just because I got too many things open on my end.
Yeah, a little bit over here too.
Why does this... I no longer get the option to down... Oh, okay. I got to do it this way.
Yeah, if you scroll over the picture.
Wow. Okay. So we're looking at 12.
Yes.
Let's see. I don't know what...
I think I want to do 30.
Okay. Can you tell me what A says? The picture didn't pick up A.
It is 10 over B minus A.
So the average value of the function on that interval is 10. Then, I got it. Then what is the integral of A of that function? Okay. Well, if we want to know what this is all I have to do is multiply both sides of this equation by B minus A. So 10 times B minus A is going to be equal to the integral from A to B of f of x dx. So we should look for that answer. C.
Okay. Okay, yeah, so distributed is C.
Uh-huh.
Okay, so then for 13, then right below it.
Okay. I can't, maybe you can read some of those to me. Okay, let's look at 13. So they're saying is that A to the N?
Yeah, it's an A.
That's just an A. I see a little, some exponent, but there's no exponent on the A?
No, it's just A to B.
Okay, I figured that'd be a huge leap in degree of difficulty.
Yeah, no, we have no idea how to do that yet.
No, I wouldn't think so. So if that's equal to A plus 2B, then what is A to B of f of x plus 3 equal to? Well,
I'm not even sure how to start it.
okay, the integral of the sum is equal to the sum of the integrals. So first of all, the integral of f of x plus 3 is equal to the integral from a to b of f of x plus the integral from a to b of 3 dx dx. Okay? We know what this is, right?
Yeah,
That's a plus
a plus
2b.
2b.
So what is this? What's the integral of 3?
3x.
Exactly. So we're going to add 3x evaluated from a to b, which is 3b minus 3a. So now we have a plus 2b plus the quantity 3b minus 3a.
Okay. And then just distribute,
Now simplify.
like terms.
Simplify, yeah. What does that give us? We got a total of 5b, and we got a total of minus 2a.
Okay, yep. Right there.
Yeah, 5b minus 2a.
Okay.
Okay? When you're taking these pictures, if you can back away just another few inches, you'll get the whole page.
Yeah, I had some shadows going there.
Okay.
So, there you go. I got some better light on. All right, I want to take a picture of the next one because it's...
You won't, or you're doing that? I didn't quite hear that. What did you say?
Well, I'm going to send you a picture of the next one.
Okay.
Super quick. All right.
Oops. Just let me close this picture out. Let me close Wolfram Alpha out. Now it won't be so taxing when I open up my email. I may just have to get a more powerful computer.
I think you got the shot.
I don't like this new Google thing for this is the third one you've sent me tonight? Yeah,
yes.
there it is. There it is, yeah. Okay, so what's the best way for me to download this? Let's see. If I double click on the paper clip, okay, okay, the download pops up there. Okay, let me pull this out, put it on my desktop. Now I can look at it.
Oh, that's the same
picture.
one we just did.
Yeah.
I sent you a different one.
Okay. I got 3 emails from you tonight, and that picture is the same as the file that was attached to the second one.
Okay, let me try this again then.
Okay. Using the
Okay.
a separate phone camera?
Yeah, you may just need to refresh.
Yeah, no, I was just curious whether you were able to take a picture with your tablet. And
No, wasn't doing that.
no, I was going to be impressed if you were.
I actually may be able to. We'll try it at the end.
Yeah, I would think you probably could do that, huh? So
Yeah, we'll try it at
14?
correct. So I ended up kind of getting an answer after like looking at the answer and just kind of reasoning it within my head, but I want the actual like explanation of it.
Okay. Let me take a look here. Let's see. Well, one way I can write this in sigma notation is 1 over 20 times the sum of the square root of x over 20 as x goes from 1 to 20. Right?
Yeah.
In other words, are you familiar with series?
I don't believe so, no.
Well, this is a series. This thing right here is a series.
Oh, yeah, yes, the series, okay.
Okay, and the first term of that series would be when I substitute 1 for x. So the first term is going to be 1 over 20. Second term is going to be, and it's a series, so I'm adding each term to the other. So the second term is going to be substituting 2 for x.
Okay.
So this series we're looking at here is this series right here that I've got in a box. Okay, and the 120 is, so now I'm going to turn that into an integral sign.
Okay.
In other words, that is the same as 1/20th times the integral from 1 to 20 of square root of x over 20. I can take the square root of 20 out because it's a constant. Let's look at the answers because I may have done too much by taking the 20 out. Let's see, which one of those looks right? It looks like
the answer is B.
Is B?
So, yeah, so, and that's just 0 to 1 square root of x dx.
Well, let's go further here. Well, I'll show you how she got B as an answer here. Okay. You accept that I can take the square root of 1/20th out?
Yes.
Okay. So now all we got to do is evaluate this integral right here.
Okay.
Well, the integral of x to the 1/2 is x to the 3/2 times 2/3. I'm going to evaluate it from 1 to 20. And you're going to see how she ends up with, well, we end up with that.
Yeah, she had 0 to 1.
Well,
which is what all...
But notice if we evaluate that, we're going to get the same answer, I bet, as if we evaluate this. And we can certainly evaluate both. Okay, first of all, let's evaluate hers. Notice what this is. That is x to the 3/2 times 2/3. Well, 1 to the 3/2 is 1, so this is equal to 2/3. In other words, the integral of the square root of x from 0 to 1 equals 2/3. I'm betting that mine is also equal to 2/3. Doing it my way. When I plug in 20 here, notice that I'm multiplying this whole thing by 20 root 20. I'm multiplying it by 2/3 times 20 to the 3 halves minus 2/3 times 1 to the 3 halves. Well, this is just minus 2/3. I can erase that and write minus 2/3.
Okay.
I'm now going to factor out a 2/3. Multiplied by 1 over 20 times root 20, leaving behind 20 to the 3 halves minus 1. You with me?
Okay.
20 to the 3 halves is the square root of 20 cubed.
Okay.
Now, that square root of 20 cancels with this square root of 20.
Okay.
Then we have 20 cubed. One of those cancels with that 20. So now we have 20 squared. So I am not getting the same answer, but what am I getting? I'm getting 20 squared minus 1 times 2/3. Well, it's possible I did a math error.
Well, how it looks is that she's saying that she pulled out a 1 to 20 on the when she's summing up each of those values. So then she's just she pulled out the 1 over 20, and then what the
Yes. Yes. And then she just had the square root of x, but how'd she get it to go from 0 to 1? Because the sigma
term is 20 over 20 is actually 1.
Yeah.
So this one's kind of just conceptually confusing to me.
I get it now. In other words, the last term in this series is square root of 1 or square root of x from 0 to 1. And the first term, okay. So I could have written the series differently. In fact, let's do that. Let me just bear with me here for a second. We'll get to the bottom of this. So let's see. If I want to pull out the bottom, root 20, then I'm left with square root of x She doesn't pull out the bottom. If I go from 0 to 1, and this is root x, the final term will be 20 over 20. But I lose all these other terms. I feel like I'm almost seeing it, but I'm not quite seeing it.
No, I'm not sure.
Let me think about this for a second. I see how she gets 1. This final term is 1.
Yeah.
But I don't understand how all these other terms are going to be square root of x. As x goes from 0 to 1. Okay, well that's almost 0. That's 1/20th. So that would be like 1/20th would be the first term, 2/20ths would be the second, 3/20ths, 1.
So is that like technically though then like a Riemann sum?
Well, I don't know what happened to the
Or
1/20th
not a
front.
Riemann.
I don't know what happened to the 1/20th. How'd she lose this? I could almost...
I believe she just pulled that in 120 times square root of 120 plus, or like plus 120 square root of 220 plus 120 square root of 320. So I think she just ended up factoring it out. So I think she's just kind of like saying the base would have been square root of x dx, because you could have plugged in anything for x in between 0 to 1 as long as it's like going up monotonically or whatever.
What did we come up with? We came up with 2/3 for that?
I believe.
And this is 1, which I'm going to multiply by 1/20th. So this times 1/20th is only 1/20th. So I can believe that adding all of these up, all 20 of them, gives you 1/3 or 2/3. But I can't see the leap she made. I'm sorry.
No worries.
If she factors...
You know that one?
Yeah. I just don't know how she loses this 1/20.
She might be doing some trick.
She's doing some trick. I just can't see what it is. And I've run across a problem like this once or twice, but it's been a while, and I can't remember the trick they use to do this. However, the method I used looked legitimate, and I'm surprised it didn't work.
Yeah.
In other words, I'm surprised I didn't get 2/3.
So,
It's possible that I did the math wrong, and I actually did get 2/3, but I don't know.
yeah.
I don't know what to tell you. I'll look at it a little bit, and if I come up with a clue, I'll let you know on Monday night. But for now, I'm going to have to go without telling you how she got that.
All right.
Okay?
Okay.
All right. Kelly,
I think I
hope that's been helpful for you. Let's see. Do I have your email address? Let me see my calendar. Oh, yeah. I'll just use the one you just sent me the stuff from. I need that so that I can send you the link to the recording of this file if you want to review it at all. It won't be available until tomorrow morning because it'll take a couple hours to process it. But I will email you that link tomorrow morning.
Okay.
Okay?
All right. Thank you very much.
You're welcome. Have a good evening, and I will talk to you Monday evening.
All right, good deal. Thank you.
All right, Kelly. Bye-bye.